Hello friends, today I will tell you how to apply PSO algorithm in LabVIEW. For that purpose, I have a problem that in which our function is 10 into x1 minus 1 whole square plus 20 x2 minus 2 whole square plus 30 into x3 minus 3 whole square, and the objective function used for minimization I use this. So using particle swarm optimization, I have to optimize this function. So in this function we use PSO, that is a meta heuristic algorithm, all we know that, in which population based stochastic search, we can also call it population based stochastic search. It is based on birds flocking, means in which, or you can say how the birds fly in a pattern to search out food or to go from one place to another place. Search for optimum value, and over here in PSO, that is particle swarm optimization, swarm means population of moving particle and flock means moving together in a crowd. In the PSO, we also use search space. The search space is the range in which the algorithm computes the optimal control variable. So just go to our function. So let's say over here, in to solve this problem, as you see over here we have three variables x1, x2, x3. So number of variables m is 3, population size let's say 5, inertia weight w max is 0.9 and w min is 0.4, and acceleration factor I just choose c1 and c2 is equal to 2, and the maximum iteration size is 50. Okay, so how we can implement this function in LabVIEW? So for that purpose I just create over here, this is a code for MATLAB. As you see, the lower bound is 000 and upper bound is 10 10 10, means using this loop we can generate a 3 cross 5 matrix which contains integer values from 0 to 10. As you see over here, I got 8 9 1 9 6 1 3 5 10 10 2 10 10 5 8. So let's just create a variable, array variable over here. Just put this value inside this. So 891, first value is 891, second value is 961, then over here this is my 961. Right now I am just using the values of this PDF only. After that I also tell you how you can compute another values also. So right now I am just using these fixed values 3 5 10, then we have 3 5 10. After that I just use 10 to 10 10 to 10, and my last row is 10 5 8 10 5 and 8. So we can generate this function, or you can say this 5 cross 3 matrix using random number. In this function over here, as you see, round is used with rand command. Round because rand command will generate values from 0 to 1, and over here the limit for this rand command is from 0 to 10, and using round it will round up my values. Like if I got 8.153, it will generate only 8. Okay, so over here right now in the lab view, as you see over here, I just create initial positions. After that I want to go to next step. Over here, initialize weight. So to initialize weight, we have to, right now in this function we require initial population size. So initial population is my this 891, the initial matrix, and I want to create initial velocity from it, and we can generate initial velocity using this formula, v into 0.1 into this matrix. You can multiply 0.2, 0.3 on the basis of your requirement. Okay, right now I am just using v is equal to 0.1. So I just go to my vi. In the second step, I already fixed this. As you see over here, this is my initial position, or you can say initial population. Then I multiply it with 0.1. It will generate my matrix initial velocity over here. So when I hit on run button, as you see, I got initial velocity. Then when I got initial velocity, as you see, v into 0.1 with my initial 5 into 3 matrix, and over here this is my variable x1, x2, x3. So I want to generate current position, and my current position is x1 is equal to initial position with initial velocity, like 8 plus 0.8, it will give me 8.8. okay, so as you see in the lab view also I got 8.8. over here my value is 9 plus 0.9, I got my current position, as you see over here. Next step in the next step, over here we have initial population and initial velocity. Then we have to apply our objective function that is used for minimization, that is fx is equal to 10 into x minus x1 whole square plus 20 into x2 minus 2 whole square plus 30 into x3 minus 3 whole square. So just go to our LabVIEW function over here. As you see, here is my x1 variable, I just separate it. So let's check how we can separate it. So over here this is my initial velocity, and over here I got my final value, that is current position. This is my current position. Okay, and from it, using index array function, I just separate. From 0th column I got x1, from 1th column I got x2, for second column I got x3. So as you see over here, this is my x1, x2, x3. So right now I want to put this ABC, and these ABC comes from over here. So let's put this ABC, and this ABC are 10, 20 and 30. These are these constants. So let's say this is 10, 20 and 30. Based on these values I got the fitness value. So the fitness value is 91964.9. let's check for this function. As you see, 1.9649, it is in multiplication of 10th factor. So over here, if you want to change it, 1.9 divided by 1000 only. Okay, so as you see over here, the values are same. Second value is 1.326. over here I got 1326. okay, Basically in the MATLAB it is, this value shows 1.9649 into 10 plus 10 e, as you see over here, 1.9649 e plus 03. E plus 03 means 10 raised to 3. So when you multiply this 10 raised to 3 with this factor, you got this value, that is in LabVIEW. Okay, so this is how we get this factor. So from here, this step 2 is completed, the objective function. Over here we have to find out the minimum value, because in this case we have to minimize. So minimum value is 1.326. So second particle we want to work with. So over here, as you see, for each particle calculate the velocity, new velocity and new position. So new velocity and new position will be calculated using this formula. Calculate velocity, v1 t plus 1 is equal to w max, that is weight factor, v I t plus c1, that is average correction factor, into r1 x best minus x plus c2 r2 g best minus x I. So from here you have to just apply this formula. So I just go to my code. So as you see over here, I got x1 x2 x3. Then over here this part will be create or will create our objective function. As you see over here, this x1 minus 1 whole square is multiplied with a, x2 minus 2 whole square is multiplied with b, x3 minus, or you can also change this to constant, it is up to you. For this particular function these values are fixed. Then you have to find out the minimum of all these three. The minimum value will be over here. As you see, the minimum value is this. From here the minimum value is second one, and the indexing for this is 1. So as you see, index function is v1, because in the LabVIEW every iteration starts from 0. So sub array is my 0.9, 9.9, 6.6, 1.1, and sub array for this means velocity is 0.9, 0.6, 0.1. In the next phase we have to apply this function. We have to calculate the velocity and position of the particle. So to calculate the velocity, I just apply this. So in this case I just go to phase 5. Over here I want to put the value 0.9, because maximum value is, as you see over here, this is 0.9 and c1 and c2 is 2. So just put these values inside this function, c2 2. So when I hit on run button, again I got x1 x2 x3. Okay, so I just increase the size. So over here these values are different from these values, because in this case we use random number. Random number will generate any value from 0 to 1, and in this case also in the LabVIEW random number will generate different values. Okay, so from here then we have to apply the position for each particle, and the position formula is xi t plus 1 is equal to xit, previous position, plus velocity, that is the same part. And over here in the LabVIEW, so this is my updated position. As you see, this is my updated position, and over here I got new variables x1 x2 x3, and from here again we have to find out the fitness value. And as you see from here, the minimum value is 1569, but if you want to check, or if you want to compare this fitness value, the fitness 2 and fitness, over here I got fitness 1, this value is less, so both from it will compare from fitness 1 with fitness 2, and which value is less, because the function is minimization, it will check p best over here, and my g best is this 136 as you see, and my g best is 9.9, 6.6, 1.1. so using this, my final updated positions are this and initial positions are these, as you see. So this is how you can, or you, if you want to go through the video, so step by step, again we have to calculate using above our particular formula. So it will compare new fitness values, and from here, as you see, our fitness value, initial fitness value, it will compare with future fitness value, and it will generate p best value. These are the p best value, as you see, from this value and this value, this one is less, it will take it. From this value and this value, this one is less, so it will take this. From this value and this value, it is less, so it will take this one. So mistakenly it is 7.217, it is 2.2179. so as you see, which one is less, it will take its position. So as you see from here, the initial positions are these and updated positions are these. Initial positions are 8.8, 9.9, 1.1, but the new fitness value for particle 1 is updated, so the positions are 9.8652. so using this, you can apply the PSO in LabVIEW. So this is how you can apply PSO. We just create these functions in LabVIEW. So this will apply your particle swarm optimization minimization problem in LabVIEW. So this is all about PSO in LabVIEW. Thank you.